Synthetic division is an alternate way of doing polynomial division, which was designed hundreds of years ago as a way to simplify the process of division. Because as you probably agree, doing division of polynomials this way is pretty tedious, takes a bit of time, and there's a lot of algebra. So the kind of the idea is to get rid of a lot of the algebra and just focus on basic arithmetic, and kind of extract the common patterns of how division works into a simplified algorithm. So let's go ahead and do it. But basically, this is how, let's say we're going to try to do this division, 2x cubed minus 3x squared minus 3x plus 2, and divide by x minus 2. If we were going to use synthetic division, what we would do is we'd actually place all the coefficients of the polynomials in order of their degree, assuming those polynomials are in standard form, within an upside down division bar. And actually, some textbooks don't use an upside down bar. Some books leave it right way up, but it doesn't really matter how you draw it. This is a much more standard way of doing it. There is no special meaning to the bars. They just help us with organizing our information. And then we place what we call the root of the divisor on the outside. And if I haven't mentioned it already, synthetic division only works when you're dividing by simple linear binomials. Basically, if it's degree 1, there's no squareds or anything like that, just x plus 4, x minus 2, or of the form x minus c. It doesn't have to be minus, it could be x plus something, and it could even involve x plus a fraction or minus a fraction, but it only works with x plus or minus something. And if you're wondering what about 0, it doesn't work with x minus 0, but that's a lot simpler to do. You don't need synthetic division to do that. But what was my point? Basically, you're going to put the value of c out here, which is always the opposite sign to the constant term within your divisor. So since I had x minus 2, I put a plus 2 here. If you're wondering, well, why do I change the sign there? That's kind of what I want to talk about. Why do we do this setup and how does this work? But before we get into how synthetic division works, let's go ahead and run through this division problem the old-fashioned way, or using long division. So I'm going to do this a little bit faster, but x will match 2x cubed by 2x squared. 2x squared will multiply into x minus 2 and get 2x cubed minus 4x squared. Then I would need to change the signs and add. Those would cancel. This would leave me with x squared. Then if I drop minus 3x, x matches x squared by plus x. X times x is x squared. X times negative 2 is negative 2x. Then I would need to change the signs and add once again. Cancel. And I would have negative x here. Dropping the plus 2 would leave me with negative x plus 2. Then if I were to match negative x with x, I could match via minus 1. Negative 1 times x would be negative x, and negative 1 times negative 2 would be plus 2. Then, as always, I need to change the sign and add, which would leave me with 0 plus 0, or a perfect remainder of 0. Again, implying that those two polynomials this original division problem, the original polynomial was divisible by x minus 2, as I was saying in the last video. 0 remainder always is special. It's just different than when you don't get a 0 remainder. And so we'd say our answer to the division problem is just 2x squared plus x minus 1, without needing any other fraction. So, what's the difference? How does synthetic division work? But basically, there's a step-by-step guide down here, which isn't perfect because I wrote it a few years ago, and I need to update how it is said. But as I said before, you're going to put all the coefficients to your dividend on the inside, which is just, again, the name of the first thing, and then the opposite sign to the constant term of your divisor right here. And what you're always going to do is take the first inside number and drop it below the second line. You always want to make a little second line beneath your upside down division thing, and the first number will always drop down. The numbers that are below the line always multiply into the number right here. So what I would do next is 2 times 2. And again, this is sometimes called C. So if you ever see C, this is what I said to do. Drop the first inner number below the line, multiply the dropped number by C, then put it under the second number. So basically, these are going to multiply, and then you're going to go to the next column. 2 times 2 is 4, and I would put that right there. Then I'm going to take these two numbers. You're always going to add the two numbers here, and this is kind of like a bar that represents addition. So negative 3 plus 4 is 1. Put that below. Then once I get the number below, that's going to multiply. It's always going to multiply over here. Like this one multiplied here, the next one's going to multiply here, and so on. And basically what you're going to be doing is you're going to be alternating between multiply, add, multiply, add, multiply, add, until you finish the problem. So 1 times 2 is 2. I'm going to put that right here. Negative 3 plus 2 is negative 1, because we're always adding these two. Once this one's here, we're going to multiply into C. Negative 1 times 2 is negative 2, and add. And instead of having to do match, multiply, subtract in repeated succession, we're always going to be multiply, add, multiply, add, multiply, add, and that is literally it. But now we're actually completely done with our division. But another thing that's important is how do we interpret our answer? And it's kind of the same way where this represented a polynomial as did this. But what we have here at the bottom, notice that the last number is the same number as the remainder, not coincidentally. And this is always the case with synthetic division. What you get at the very end is always the remainder to your division problem. In this case, 0. And that's not part of our answer. That's part of, like, if we were going to write it, our answer as a fraction, that would be the numerator of the fractional part. But since it's 0, we don't need the fraction. And then everything over here, all the other numbers are going to be representative of the quotient, the answer to the division problem, which notice is the same as the coefficients that we had here, 2x squared, x, and minus 1. And they're always in succession because it's sort of like up here, this corresponded to a polynomial of degree 3. After I've succeeded through division, the answer's at the bottom here, and the answer at the very bottom is going to lose 1 degree. Because if you take x cubed and you divide by x, it would make sense that it would come down to x squared. And that's kind of how I know, well, this is 2x squared, this is x, this is minus 1, and they're always arranged in that sort of succession. So, sort of summary that, after all is said and done, what I get is my answer is 2x squared plus x minus 1. And again, that's synthetic division. Now, it took kind of a while here because I was trying to explain how you do it. And also, before I move to the next video, I want to talk about, well, why did this all work? Because it can kind of seem like magic if I don't really think about the steps involved. In the next video, I'll do a couple more examples, and I'll do them a little bit faster. Because the benefit of synthetic division is that it's very, very fast once you get the hang of it, and you can divide polynomials with very, very little effort. And it takes a lot less room and space and thinking than long division of polynomials. But the weakness of synthetic division is, well, we kind of have to understand how to do it, obviously, and it only works when you're dividing by x minus c. So say I wanted to do problem number 2 up here, we cannot do this problem synthetically. It can only be done with long division. So long division is still necessary sometimes because synthetic division only works for dividing by degree 1 polynomials. But, excuse me. So the last thing I want to say is, well, why does synthetic work? Why does this exact process happen the way it does? And if you kind of pay attention to the numbers that we got, notice that the first step was to drop the 2, and that was the exact same thing that we got when we were matching to begin with. Like we had the 2, and basically the numbers that are below the bar always match. And that's because when you're dividing by a very simple factor such as this, the way to match the leading coefficient to with 1 is always just getting the first number. So you always drop because it's always going to be a perfect match to a simple 2x cubed with x. And we're always ignoring the x, the various powers like x squared in the synthetic division. And that's kind of the benefit, is we don't have to worry about all the algebra. We're just doing the arithmetic. Then what we do next is we multiply 2 into x. Well, this thing will always cancel, but what we note is what we get from that. 2 times minus 2, we get negative 4. And since we change the sign, that is the reason why you always change the sign right here. Because at every one of these steps, like the thing I taught you was, well, when we subtract, we change the signs and add. But if I just change the sign right here and switch it from negative 2 to positive 2, that will account for the change of sign. And that's why I'm always multiply, add, multiply, add, multiply, add. Technically, if you didn't change the sign, what you could do is you could multiply, subtract, multiply, subtract, multiply, subtract. That would also work. But as you can probably agree, adding is easier than subtracting. The reason why it's been built this way is because it's been, pretty much proven that people are better at adding than subtracting, and you'll be less prone to mistakes. But anyways, then when we added negative 3 plus 4, what we wound up with is 1, and that's the result we get here, which is of course then matched with, we matched this with this, which was a match by a coefficient of just 1. And, you know, then we move on, right? The 1 will multiply into here. 1 times minus 2 would give me 2, and then I would change the sign. And that's exactly what we get in the next step. We just do 1 times 2. So we're basically cutting out all of the algebra, shortcutting the process. And if you learn that process, you know, it's much simpler than having to actually do all of the polynomial math over and over and over again. But you always have a choice. If you're dividing polynomials like this, you can use either method. I strongly recommend synthetic division because it is so much easier and faster and better. But again, you still need to know how to do long division because some polynomials cannot be divided synthetically.